Yeah. So today topic. So previous classes, course information explained very clearly about course information given very clearly. And then, so yesterday Java overview given. So day one, day two. Yes, day one, first day. So about myself, about course information, about course content, prerequisite, all this explained yesterday. Day one, just only course information, nothing discussed on day one. Okay, fine. Next day two, yesterday day two. Day two, just Java overview. Java not started yet. So what's complete Java overview given yesterday? It's like what is Java, Java history, these things given. Nothing discussed yesterday also. Just only Java overview given. Of course, all these topics will be repeated once again. These topics will be repeated once again. Yeah. Today, yes, starting from the basics. Yes, starting actual classes from today. So last two classes, just only introductions, introduction about course and Java overview given. Today, starting actual classes. Okay, fine. Yes, starting from the basics. Starting from the basics. See, before going to Java, there are some basics. Before going to Java, there are some basics here. So basics like yes, about ways, what is operating system? Next about yes, interpreter on the compiler. Next low level languages. Next high level languages. Okay. Yes, like exe file. Next dot class file. Right. There are some basics here. So once you cleared about all these basics, then easy to understand Java. Directly, I'm not starting Java. So before going to Java, there are some software basics. There are some software basics. Okay. So after finishing all the software basics, I think today, tomorrow, all the software basics. And then we go for Java. Okay, 2 days, all software basics. And then we start Java. Right? Yes, software basics. Yes, I'm starting from the basics here. One second. So this is your class document. Yes, class document. See here, you guys are not necessary to write in running notes. Running notes is not necessary here. It's there in document here. I have prepared very clearly. So this document for you only. So this is around 900-page document. Complete core Java document. Core Java document, advanced Java documents. Yes, frameworks for each and every topic. Separate documentation is available. So this is first initially core Java document. Yes, starting from the basics. Okay, today starting from basics here. So basics. Right? See, basics. Starting from the basics. So starting from the basics. Yes, I'll go very slowly, neatly here. So you guys don't worry. So running notes is not necessary. I have prepared very clearly. So starting from basics. So without any IT background also anyone can understand it here. Without IT backgrounds. To yes, to understand Java, to learn Java, IT background is not necessary. Even non-IT yes, students also can understand Java here. Like mechanical, civil, maybe pharma background, science background. So whatever it is, mathematics background, whatever it is, any background you can understand here. Yes, I'm starting from basics here. Okay. See, computer aware. See, computer aware basically two categories. Computer aware basically two categories. Okay. So first one, hardware. First one, hardware. Second one, software. Hardware and software. Hardware and software. So what is hardware? Hardware, these are physical components of a computer. Hardware. So these are physical components. So physical components of a computer like keyboard, mouse, monitor. motherboard, RAM, hard disk, all the hardware components. Those components we can touch, but not necessary for us. We are the software engineers. So let us start with software here. Okay. So hardware, see here, hardware, these are physical components. So that is not necessary for us. Yes, we are the software engineers. So let us start with software here. Software. So what is software here? See, software, in software, yes, everything is a program. In software, everything is a program. In software, everything is a program. In software, everything is a program. Yes, it's a collection of programs. It's a collection of programs. All are programs in software here. So started from the basics here. Before going to Java, there are some software basics. If you good at software basics, then easy to understand this. Okay, today started actual classes. So last two classes, just only introduction given. Today, actual classes started. So before going to Java, there are some software basics. First, let me clear about all the basics, then easy to understand Java. Okay. Yeah, computerware. Computerware basically two categories. So first one hardware, next one software. So hardware means these are physical components of a computer. Hardware is a physical components like keyboards, mouse, monitor, hard disk, RAM, and all the hardware components, but not necessary for us. We are not a hardware engineers, not necessary for us. Yes, our topic is software. Let us start with software here. See, in software, everything is a program. It's a collection of programs. Collection of programs like C, C++, Java, OS programs. All the programs comes under, yes, software. Right? It's a software basically two categories. Basically two categories. Software basically two categories. Two categories. Software basically two categories. Two categories. So first one, system software. First one, system software. First one, system software. Second one, application software. First one, system software. Second one, application software. Application software. Application software. System software and application software. Software basically two categories. First one, system software. So next one, application software. System software and application software. What is system software? Let us say about system software. So what is system software? System software, it interacts. System software, it interacts. It interacts with the hardware components. It interacts with hardware components. It interacts with hardware components. So system software, it interacts with hardware components. System software interacts with hardware components. Yes, example, system software, best example is operating system. Yes, operating system is a system software. So system software is a best example for it. It interacts with hardware components. Okay, system software, it interacts with hardware components. Example OS. OS is a system software. OS comes under system software, right? So next one, application software. What is application software? See, application software, yeah, this one for the purpose of application development, for the purpose of application development, for the purpose of application development, for the purpose of application software, for the purpose of application development. Yes, application software. So this is for the purpose of application development, for the purpose of application development, applications, apps. See, in our daily life, we are using many applications, right? In our daily life, we are using many applications. See, in our mobile, there are many applications. In our mobile, there are many applications here. So, which is mostly used application in your mobile? Yes, anyone please respond. So, which is mostly used application in your mobile? Yes, in your mobile, there are many applications using, right? Yeah, which is mostly used application in your mobile? Anyone please respond. Which is mostly used application in your mobile?
WhatsApp, Instagram.
Yeah, WhatsApp. Instagram, these things, right? Okay, fine. Yeah. So most used application WhatsApp, right? WhatsApp, WhatsApp, Facebook. So there are applications here. WhatsApp, Facebook, online trading applications, online trading. Yes, like food delivery apps, e-commerce applications. So next, banking applications. Like there are many applications, banking apps. Yes, even Zoom application also. Zoom is also one application, right? Zoom applications, Zoom meeting app, right? Zoom app. These are all the applications. So all their applications, right? So all their applications. To develop these kind of applications, we need some software. See, application software for the purpose of application development. So these are some applications. To develop this kind of applications, we need some software. So that software is application software. See, there are many technologies. Okay, in software world, we have many technologies. More than 100 technologies available here. Many technologies. So which is exactly application software? See, there are many languages. There are many languages we are using. Okay. Yes, there are many tools we are using here. Languages, tools, and packages. Like that, there are many things we are using. Okay, many languages. Yes, like see, application software. Best example, Java. Java is application software. Java, yes, C and C++ application software. Next, Python. So Python. Next, databases. Okay, maybe Hadoop. Like this, there are many things here. Yes, next, .NET. There are many things, right? There are many application softwares here. So here there are many languages, tools, and packages. There are many things we are using. Language like Java, C, C++, Python languages, tools like testing tools, data analytics tools, like big data tools. Like that, there are many tools we are using. Packages like ERPs, like that, many things we are using, right? So which is exactly application software? Which is exactly application software? See, here, system software interacting with hardware components, interacts with hardware components. Only only voice can interact with hardware components. So voice is a system software. Only voice interacting with hardware. So voice is a system software, except voice. Except voice. See, except operating systems. Yes, remaining all are. Yes, remaining except ways remaining all are application softwares, all are application softwares, all are application software except ways. Remaining all are application softwares except ways. Okay, so except operating systems, remaining all are application software. Okay, so whatever it is, so except ways, remaining all are maybe testing tools. Yes, maybe AWS tools, that infrastructure management tools, AWS tools, DevOps tools, or maybe some languages, packages, all comes under application software, except OS, remaining all are application softwares. See, operating systems. Yes, example, Windows is a OS, right? Windows is a OS, right? Windows OS. Yes, any other operating systems? Yes, you guys, anyone? Can you tell me other operating systems apart from Windows OS?
Linux.
Linux, good. Linux. Yes, any other operating systems? See, Linux. Shortly, I'm going to start Linux classes also. Yes, I have the good experience in Linux also. I'm going to start Linux also shortly. So Windows OS, Linux OS, and next what? Mac OS, right? Mac OS. Mac OS and Unix, very old operating system, Unix OS. Okay, Unix based Windows, Linux, Mac. Yes, Unix. Okay. And next, Android, right? So Android OS, Android and iOS. So these all are, so these Android, iOS, mobile operations, right? Remaining all are laptops, desktops using here. So operating systems, except these operating systems, remaining all are application softwares, except OS. except with all our application softwares. What are things we are using? Maybe AWS, maybe DevOps, maybe testing tools, maybe big data tools. Okay, maybe Salesforce, maybe C++, Java, HTML, .NET. All our application softwares. All our applications simple. So except these operating systems, remaining all our application softwares. That's it here. Okay, right? Fine. So it is system software and application software. Only voice comes under system software and rest of the technologies except voice. Rest of the technology comes under yes application software. Okay, fine. Okay, so this is about system software and application software. Same thing is there in document here. See the document. Yes, introduction to software. Software is a collection of programs such as C, C++, Java, and all these, right? Okay, next. Software basically two categories. Software. So first one, system software. So next one, application software. System software, application software. Same expand here. It interacts with the hardware components. Example ways. Application software for the purpose of application development, apps like WhatsApp, Facebook, online trading, and all these, right? Examples. See, except operating systems remaining all are application software. The same thing is in document here. Just you can follow document here. This document I'll share with you. Okay. Yes, diary recordings and documents both I'll share with you. Okay. Yes. So I'll give the drive access. So today, today night, yes, I'm going to create a drive. Yes, upload drive. I'll give the drive access. For all paid students, immediately I'll give the drive access. Today night itself, I'll give the drive access. Okay, fine. So this is about this now. Okay. So let us say about what is voice. Okay. See, a system software, application software. Yes, Java comes under application software. Java is a application. As per my explanation, Java comes under application software. Java is a application software. So our topic is about application software. Before going to application software, let us see something about OS, about operating systems, about operating systems. Let us see about OS here, about OS, operating systems. Yes, here's some question for you guys. Very simple question. Very simple question. Very simple question. Can we run any program without voice? Very simple question. Can we run any program without voice? It's a very simple question. Anyone can answer this? Anyone, please? Can we run any program without voice? Very simple question.
I think no.
No. Answer is no. Right? Answer is no. No. Without voice, we can't run any program because if no voice, no computer. Without voice, no computer. No voice, no computer. So can we run any program without voice? Answer is no. No, we can't run. See, except bias. Except bias to run all software programs. Voice requires. Voice requires. What is bias? Bias is not a software here. Except bias. Except bias to run all software programs voice requires. Bias. So bias is not a hardware. Bias is not a software program. Bias is also a program, but it's not a software program. So what is bias? Bias stands for what? Yes, anyone can you give the abbreviation for the bias? Bias abbreviation. Anyone idea? Bias abbreviation. Very simple question. Bias abbreviation. Abbreviation, yes, bias stands for basic inputs and outputs system. Bias stands for basic input output system. So here bias stands for basic input output system. So what is bias here? So bias, yes, here bias, yes, bias is a hardware program. Hardware program. Yes, it's a chip level program. Yes, it's a chip level. is a chip level program. So BIOS is a chip level program. This is a BIOS chip in computer. Let me show that. Yes, BIOS. BIOS stands for Basic Input Output System. So BIOS is a hardware program. It's a chip level program. Let me show the BIOS. 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 Yeah. So this is BIOS image. See, this is BIOS. BIOS, right? BIOS. Yes. What's the task of this BIOS? What's the task of this BIOS? What it will do here? See, when you power on system, so first of all, power goes to BIOS. First of all, power goes to BIOS. Here, this BIOS chip is a hardware, right? This BIOS contains one program, BIOS program. That BIOS program is responsible. So this BIOS program is responsible to boot our operating system here. Booting ways. Booting ways means, yes, see. So OS inside the disk, C drive, T drive, hard disk, right? Hard disk and RAM memory. Hard disk. Hard disk contains, see here, hard disk. Hard disk contains OS. Yes, in hard C drive is Windows OS, right? Windows OS. So when you power on system, so once you power on system, first of all, power goes to BIOS. Power goes to this BIOS here. This BIOS loads the OS. Loading OS from hard disk, C drive, hard disk to RAM memory. So that process is a booting process. Loading OS from hard disk to RAM memory is a booting process. See, here is a OS, Windows OS, right? So Windows OS, this is running inside the RAM memory. So inside the RAM, so OS is running inside the RAM memory here. So what's your task of BIOS? See here, BIOS. So BIOS is responsible. BIOS is responsible. BIOS is responsible. Responsible. BIOS is responsible to boot operating system. To boot OS operating system. To boot operating system. Okay. So to boot operating. So here BIOS. That BIOS program is responsible to boot operating system. So what is booting here? Booting is a process. Booting is a process of loading. Yes, loading OS from hard disk to RAM memory. Yes, from hard disk to RAM memory. RAM memory. Yes, booting. So what is exactly booting? Yes, booting is a process of loading OS from hard disk to RAM memory. So always OS inside the hard disk. Hard disk is for the storage. OS storing inside the hard disk. OS storage inside the hard disk. Here is Windows OS, right? So once you power on your system here, so first of all, power goes to BIOS. This BIOS program is responsible to load OS from hard disk, to RAM memory. So here this RAM, here this OS is running in RAM memory. Now here OS is running in the RAM memory. Now this OS is responsible to process everything, every request processing by the OS only here. So this OS, so Windows OS, here is a Windows OS. This Windows OS running inside RAM memory. So this OS is responsible for all here. Every request processing by the OS. Every request goes to OS. That's it, right? Yes. Okay, fine. So BIOS. So BIOS stands for Basic Input Output System. Basic Input Output System. Okay, so BIOS is responsible for the booting OS, right? Yes. Now let us say what is operating system. Yes. Topic is about operating system. What is OS? So what is operating system? What is operating system? Let me explain clearly. So what is exactly OS? What is OS? See, computer. In computer, there are some layers in computer. There are some layers in computer. See, so first of all, hardware, right? All hardware components. Hardware components. On top of hardware components, who is running? So who is running here? Who is operating systems? Operating system. Operating system. Yes, on top of which all programs like C and C++. Next maybe Java program, maybe Python. Okay. maybe databases. Yes, even for MS Office also who is required. MS Office like this, right? Who is required? Okay. Yes, all their application software, all their application softwares, all their application softwares. So their application softwares, all their application software. So all their application softwares. Okay. Yes. So there is a hardware components. On top of hardware, there is a OS running. On top of OS, all the application softwares like C, C++, Java, so Python database, like all the application softwares, right? All the applications are softwares running on top of OS. 1 second. Right? See, hardware components, on top of hardware, this OS, on top of OS, all programs running. So these all are application softwares. All the application softwares running on top of OS. Simply OS giving platform. OS just it's giving platform. So OS just it's giving platform. On top of it, all are running. C, C++, Java, and all they are running on top of OS only. So it's giving platform. So OS just it's giving acting like a platform. On top of it, all is running, right? All are running. So what is OS means? It's a platform. So OS is a platform. It's a simple answer. It's a platform. It's a platform. It's a platform. Yes, where we can run. It's a platform. So where we can run all application softwares. It's a platform where we can run all application software. Where all application software. It's a platform. Right? So what is OS? Simple answer. It's a platform. So OS is a platform. OS is a platform where we can run all application software, all application software. Okay. See, not only platform, not only platform. Suppose C program, C++, Java, these programs generating some output. Yes, output of all the programs. Output of all these programs, first of all, transfer to OS. See, output of all these programs, first of all, transfer to OS, and then finally deliver to output device. The deliver to output device. See, here output of these programs. So first of all, transfer to OS, and then will deliver to output device, maybe monitor. So between application software and hardware components, there is a OS. Suppose reading from the keyboard, input data, data input. So first of all, input goes to OS. Your input goes to OS from keyboard, hardware components, keyboard. That keyboard data goes to OS. Keyboard data goes to OS here. From the OS, simply transfer to these programs. So when you're reading data from the Java program, when reading data in Java program, so first of all, keyboard data goes to OS, from OS to Java program. That's it here. So between application software and hardware, there is a OS. So it's a middle layer, like a mediator. It's like a mediator between application software and hardware components. Okay. Yes, it's a mediator. It's a mediator, like a interface. We can say it's an interface. It's an interface. Okay. So it's an interface. It is an interface. It's an yes interface. Interface between application software layer. Yes, it's an interface between application software layer and hardware components. And hardware components. So these two layers. So between these two layers, OS acting like interface. It's an interface. Okay. So OS is an interface between yes application software and hardware components. Fine. Next, one more thing here. See, so these are application software, right? Yes, OS comes under what system software. OS is a system software. It is system software, right? OS is system software. OS is a system software. OS is system software, right? See, this whole thing is computer. Whole thing is computer. See, in computer, here there is a hardware. In computer, there is a hardware. Hot up hardware. So software, right? See, same thing discussed here. Yes, computer ware, hardware and software. Hardware and software. So hardware and software. So hardware. Next step. Software. See, software, system, software, application, software, right? Software, system, software, application, software. See that? Yes, application software and system software, right? Okay. See that. Just observe it here. See this. So this whole thing is computerware. In computerware, this here is a hardware. Are these two layers? Software. Software. See this software, system software, application software, system software. So system software and application software. That's it here. So these two layers is software, this is hardware. On top of hardware, software is running. In software, there is application software and system software. So here OS comes under system software. OS is system software. So here OS acting like a platform. OS acting like a platform. On top of OS, all programs running. So what is OS means? It's a platform. It's a platform where we can run all the application software. It's a platform where we can run all the application software. Right? Yes, next. Not only platform here, interface. It's an interface. So between application software and hardware components, it's an interface. Okay, it's an interface. It's an interface between application software and hardware components. That's it. Right? Next, one more thing. In Java perspective, one more some point here. In Java perspective, some important point. See, inside of OS, this library. This library. Library contains input-output functions. Input-output functions. Library contains some input-output functions. Okay. Yes. See, this library, every OS has its own library. Windows OS its own library. Linux has its own library. Mac has its own library. Every OS has its own library to communicate between yes application software and hardware components. So OS in every OS there is a library. Yes, OS using just operating system. Yes, it will be using library to communicate between application software and hardware components. Okay. So library, it's a collection of input output functions. Every OS contains library. Every OS is library. That library is to perform IO operations. Input output function. There are input output functions here. Okay. So every OS. So every OS. 1 second. See, every OS has its own library. Its own yes, its own library. Every OS has its own library to communicate between application software and hardware components. So instead of OS, this library. Okay. So every OS has its own library to communicate between application software and hardware components. So every OS that library is there. So that library. So this library is responsible to communicate between yes application software and hardware programs, hardware components, right? Okay. Yes. Yes, somewhat important point, useful point for the Java here. Okay, next one more point here. See, C program, C++, Java, all the programs, right? So before going to run these programs, first of all, so these programs, maybe C program, C++, Java, all the programs, first of all, linking with OS library, half linking, then communicating with the hardware components. So every program has to link with OS library. Here, every program has to link with OS library before going to run it here. So that link may be statically linking or dynamically linking. Statically or dynamically. So what is statically, dynamically we'll discuss next. I'll explain. In Java, I'll explain here. Statically linking, dynamically linking. That point we'll discuss in Java. So later we'll see. Right? So every program, see here, every program. So every program has to link with OS library. Link with OS library. Yes, before going to run it here. Before going to run it. Before going to run. So compulsory has to link. So this is somewhat important point in Java perspective. In Java, I will explain statically linking, dynamically linking. Statically, dynamically. What is statically, dynamically? We'll discuss next. I'll explain very clearly. Okay, right? Yes. So that's all about OS. So what is operating system? What is OS? Simple answer. It's a platform. OS is a platform where we can run all application softwares. OS is a platform where we can run all application softwares. Next, it's an interface. It's an interface between application software and hardware components. Interface. It's a platform and interface. That's it. That's all about OS. Same points explain document also. See this document here, OS. Same thing is in document. Nothing missing. Everything is a document here. You can follow document here. Operating system. See, first question. Can we run any program without OS? No. See, except BIOS. Except BIOS to run all programs OS requires. Okay, right? Yes, BIOS stands for Basic Input Output System. So BIOS is a hardware program. It's a chip level program. Yes, BIOS is responsible to boot operating system. So what is booting? Booting is a process of loading OS. Booting is a process of loading OS from hard disk to RAM memory. Yes, booting is a process of loading OS from hard disk to RAM memory. So that's all about BIOS. Right? Next, what is operating system? Same thing points here. It's a platform, it's an interface. Same, that 4 points explained is there in document here. So what are things explain the document? Yes, in class, same thing can see in the document here. So what are the topics? So what are the topics explain the notepads and in your class? Everything can see in the document here. Nothing missing. Every point you can see. Right? Fine. See. It's there. See this hardware, operating system, and application software. Everything is in document here. Okay, fine. So that's all about OS. All right. Yeah, this information needed to understand Java. Yes, you must have this knowledge. Okay, fine. Now Java comes under application software, right? Java is the application software. Now our topic is about application software. Let us move to application software. Application software. See, in application software, there are two categories like front end, back end. Front end software and back end software. In application software, there is a front end and back end. So what is Java? Front end software, back end software. Let us see. Java front end, back end. Let us see. See, this is web application. Here, here it's a web application. Artix is like this. Web application. In web application, here is a front end. Okay, so yesterday some little bit discussed about this web application. Okay, so here front end, next is a back end, front end, back end. So front end, it's a browser environment. Front end is a browser environment. Okay, so there are front end technologies like HTML, CSS, JavaScript, jQuery, and all front end technologies. Front end technology, right? Back end, yes, application and database, right? Application type, database type. In application type, yeah, this is Java, right? So Java comes on what here? Back end. Java is a back end. Java is a backend software. Java is a backend. So Java comes and see Java is a backend software to develop the server side applications. Okay, Java is a backend software. Java comes under backend here. Java is a backend software to develop server side applications. Okay, yes. Here one more thing, JavaScript is there. JavaScript, Java both are not same. Java different, JavaScript is different here. See, JavaScript and Java are not same. Different, they are different things here. So JavaScript using at the client side, it works in the browser environment. So JavaScript using at the client side, it's a browser environment. Java using at the back end. So JavaScript is the front end in browser environment. So Java is a back end. Okay, right? Yes, JavaScript. JavaScript using at the client side. Okay, whereas Java at the server side. JavaScript is a browser understandable language. Java is a JV understandable language. That's the difference here. Java and JavaScript both are not same here. Java, JavaScript not same here. Different. JavaScript working at the front end. It works in the browser environment. Java working at the back end. So Java is a JVM understandable language. JavaScript is a browser understandable language. That's it. Difference. JavaScript at the front end. Java at the back end. JavaScript comes on the front end. Java is a backend. Okay, fine. Right? Yes. Next. So what is Java now? Java is a application software. Yes, is a backend. So Java working at the backend always here. Right? So Java is a backend application software. Java is a backend software. Java is a backend software. Clear, right? Next, here front end, backend. Here also we have some language and packages. Packages ready, medium, and ready to use, like ERPs, accounting package, MS Office, all that package. Language. So Java comes on language here. So language here, it's a programming. Languages, yes, it's a programming language. It's a programming or some coding, right? Like C, C++, Java, all their languages. So Java is a language. Java is a programming language. Java is a programming language. Java is a programming language. Now let us say about languages here. Languages. Languages. Language. Languages. There are two things in this. Yes, in software, there are two things here. First one, yes, user understandable language. First one, yes, first one, see, computer understandable language. See, computer understanding some language, our language different, computer understandable language different, not same. Our language different, computer understandable language different. Yes, computer understandable language, computer understandable language, computer understandable language, and next user understandable language, user understandable language, computer understandable language, next user understandable language. So computer understandable and user understandable language. Yes, what is computer understandable language? See, computer understanding some language, we are understanding some language. Our language is user understandable language. Yes, what is computer understandable language? Yes, computer understandable language. It depends on generation of computers. It depends. It depends. Yes, it depends. Depends. Sorry. Depends on generation of computers. Computer understandable language depends on generation of computers. Yes, generation of computers. Okay, that depends on generation of computers. So computer understandable language that depends on generation of computers here. Yes, next one more question for you guys. One more question. One more question. How many generation of computers? Anyone can you answer this? How many generation of computers? Very simple question. How many generation of computers? Anyone can you answer this? How many generation of computers? Just you search in Google, you can see all the generations here. How many generation of computers? Yes, anyone can you answer? How many generation of computers? Yes, there are 5 generations. How many generations? So 5 generations. 5 generations. 5 generations of computers. There are 5 generations. There are 5 generations. So first gen. So what is first gen computer? There are 5 generations. So what is first gen computer? Yes, what is first gen computer? Vacuum tubes. Okay. Yes. Sorry. With vacuum tubes. So first one vacuum tubes. Sorry. Vacuum tubes. Okay. Yes. So first one vacuum tubes. First generation vacuum tubes. Yes. Now you can tell. Tell me what are other generations? So first one vacuum tubes. Sorry. First one vacuum tubes. What is second generation computer? Second gen. Anyone idea? Second generation. Transistor based. Transistors. Transistors based. So first generation vacuum tubes. Second generation transistors based. Yes. What is third gen computer? Third gen. Third gen computer. Third gen IC based. Yes, electronic is anyone is having electronics background, maybe having this knowledge. Yes. So there are 5 generations. First gen vacuum tubes, vacuum tubes. Second generation transistor based here. Third generation IC based. Fourth gen. So what is fourth gen computer? Fourth gen. Fourth gen. Yes, is a processor based. It's a processor. So processor based. Now it's a current. Yes, present generation. So this is present generation. Presently we are using processor based computers. Okay. Sorry, 1 minute. Let me have some water. Yes, first gen vacuum tubes, second generation transistors based here, third generation IC based, fourth gen processor based. It's a present generation, right? Next, fifth gen. Yes, it's a feature. Yes, what is feature generation computer? Yes, anyone idea? What is a feature generation computer? What is a feature generation computer? Anyone idea? No one? Feature generation AI based computer. Yes, what is AI based computer? I'll explain. Okay. So presently we are using processor based computers. Feature AI. Yes, about AI also I'll explain now. Okay. So presently we are using processor based. Yes, processor based. Processor based computer. Processor based computer. Understandable language. Understandable language is binary codes. It's a binary codes. Binary code, right? So binary codes. So what is binary codes? So binary code is in the form of zeros and ones. Called binary codes in binary formats. So this is binary code zeros and ones. Yes, how that binary code generating? Java I will explain. Java I will explain that very clearly. So processor based computer understandable language is binary code. So binary code zeros ones formats. So this is about present generation computer. So this is present generation computer understandable language, processor based, right? Next, yes, AI based feature. This is feature. This one feature. So what is AI based computer understandable language? Yes, anyone idea? AI based computer understandable language is what is AI based computer understandable language? AI based machines. AI-based machines understandable language is English. Yes, it can understand our English. Okay. AI-based computer understandable language English. It can understand our English here. So what is exactly AI? Artificial intelligence, right? So what is artificial intelligence? Okay. Artificial intelligence. So what is exactly AI? Let me explain clearly. So what is AI? AI here. Artificial intelligence. What is AI? It's a technology. Okay. It's a technology. So AI is a technology. It's a technology. It's a technology to make machines work like a yes human being. Work like a human being without human intervention. So work like a human being. Yes, work like a human being without human intervention. Without human intervention. So working like a human. Okay. So AI is a technology. So AI is a technology here. AI is a technology to make machines so working like a machines working like a human being without human intervention so without any human intervention yes working here that AI machines same exact like a human being So like a human, it works like a human being. Okay, right? Like it without human intervention, right? Suppose, for example, here, for example, yes, let's make some example. Suppose A-based mission. Suppose in your home, A-based mission is there. That it can understand your English. Suppose in your home, any A-based tool or A-based machine, any A-based device, that A-based device can understand your English. That A-based machine can understand your English. So what are you saying that English? It can understand your English. Okay, it works like a human being. Yes, it will listen. That A-based device can listen for your voice and text data. Yes, that AI-based machine will take your voice data and text data. So what are you saying? It will listen for your voice. It can understand your English, even text it also. See, like a human being. See, today I'm explaining all this, right? It's a text. See here text. At the same time, I'm explaining that. So you understanding text. You understand this text as well as my voice, right? Both. So AI machine also same, exact same. Yes, that A device also same here. Yes, it can understand your voice or text. So A device for the device here. Yes, your input can be text or voice. So you can voice based input or text based input. Any input you can take it here. Okay. Next, one more example, Tesla car. In yes, this is a Tesla car, right? Tesla. Tesla car. Yes, it's A based car. Tesla car is A based car. A based. Tesla is a based car, right? A based car here. So with the driverless. Yes, Tesla car driverless without driver. Is driverless car. Driver is not necessary here. So without driver. Okay, driverless car. Yes. So the Tesla car once integrated with your mobile, the thing is it has to integrate with your mobile here. So once integrating with your mobile, yes, using mobile, you can operate the Tesla car here. So whatever the instruction it says, it will listen for instructions. Okay. It will go to required location here. It will go to some destination and picking persons and picking whatever that. Okay. It will pick persons. Okay. Maybe some goods, whatever it is. It will pick all of those things, right? So the Tesla car is a based car. Okay. So without any human, it will work here. Without driverless car. Driverless car. Like this, there are many AI devices. Even healthcare devices also came nowadays. AI-based healthcare devices that will monitor your health. For example, AI-based watches. See, I'm using AI-based watch already. AI-based watch. That AI-based watch will monitor my health here. So my heartbeat, next my ECG, and all that here. So daily, yes, walking, how many foots, and all this here. Okay, that kind of healthcare devices. So healthcare devices next. So not only healthcare, even AI machines like workers. So wherever manufacturing, yes, manufacturing companies, they're like a workers. So using AI-based machines, yes, we can make it fast here. Okay. Yes, like a driver. AI-based machines working like a driver. Yes, like a engineer, like a doctor. Okay, like everything here. So we in place of human, AI machines working here. The thing is, as a human, you have to utilize that AI-based machine properly here. Okay, as a human being, we should utilize AI-based machines or tools. Okay. Yes, using AI tools, yes, we can generate some code. That code you can integrate with your application, right? Yes, we can build the applications using AI machines, using AI tools. Using AI tools, we can develop the applications here. Okay. So here, without writing much code here, using AI tools, we can take that code. Yeah, that code we can customize as per your requirements. Okay. So AI generated code, we can take it and we can customize. After customization, we can build the application. Yes, your task is because very simple. So need to write much coding also. So once using AI-based tools, so not necessary to write much coding. So one day I'll explain about AI-based tools also. One day I will take AI-based tools. Okay. So how to generate code, how to integrate in application and all that I'll show. I have the experience with AI-based tools also. One day I will take that class also. So about AI, right? So AI-based, okay. Yes, AI-based. Computer understandable language English. Now presently we are using processor-based computer. Yes, it's a binary code. So this is called as low-level language. The system understand processor-based computer understandable called as low-level language. Okay, computer understandable language is a low-level language. It's a low-level language. It's low level language. Low level language, user understandable language, high level language. Low level language and high level language. So languages, in software languages, there are two categories: low level languages and high level languages. Low level and high level languages. Okay. Yes. Low level languages and high level languages. In software, there are two categories of languages. So first one, low level language. So what is low level language? Yes, it's a system understandable language. It's a understandable, system understandable, system understandable language. Yes, low level language. It's a system understandable language. Here, system means processor. System means processor. System means processor. Right? Yes, it's a processor understandable language. It is a processor understandable language. Understandable. Processor understandable language. Okay. Yes, it is in the form of binary code. Yes, it is in the form of binary codes. It is in the form of binary codes. Binary codes like a zeros ones format. Zeros ones format. Binary code. This binary code is called as machine language. Yes, it is called as. Yes, it is called as machine language. 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 Low level language. It's a system understandable language. Low level language, system understandable language. Yes, system is processor. Yes, we have the microprocessors like 8086, yes, and 8 farad. So old one 85, 8085 and 86. Now presently we are using, yes, 86 computers. Right? Yes, 8085, 8086. Okay. Yeah. It's a process understandable language. It is in the form of binary codes. It is called as machine language. It is called as machine language. Low level language, it's a machine language. Right? So second one, high level language. So what is high level language? It's a user understandable language. High level language, yes. It is a user user understandable, user understandable language. It's a user understandable language. It's a user understandable language. Yes, it's like English. User understandable. Yes, it's like English. It's like English. Yes, example. High level language example. Java. Java is a high level language. Yes, example Java. Java. Next C and C++. They're high level language. Python. These all are high level languages. HTML. These all are high level languages. High level. It's a user understandable language. Yes, it's like English, like Java, C, C++, Python. They all are high level languages. So low level languages and high level languages. Okay. So high level. So Java comes under high level language. Low level language, machine language. Right? Yes. So here low level and high level. Right? So Java program, C++ looks like English language. But system cannot understand this language here. These high level language has to convert into low level language, machine language. Who will convert here? Yes, high level language to low level language. High level language to, yes, low level language. High level language to machine language. So which one will convert from high level language to machine language? Anyone idea? So which one will convert? So which is converting from high level language to machine language? Compilers or interpreters? Yes, compilers or interpreters. Compilers or interpreters. Compilers or interpreters converting compilers or interpreters. Converting from high level language to machine language. Either a compiler or interpreter. So compilers, interpreters. some language compiler based. For example, C and C++ compiler based, Python interpreter based, like that here. So compilers or interpreters converting from high level language to, yes, high level language to machine language. From high level language to machine language. So converting either compiler, interpreter. See, compiler, interpreter, both are doing same jobs, but some difference is there. Yes, compiler, interpreter, both are to convert from high level language to machine language. Both are doing same job, but the way it's working is different. So compiler, interpreter. What's the difference between interpreter and compiler? We'll discuss. Wait. Okay. See, today topic. Let me show you the document here. So today topic. So this is today topic. Introduction to software, system software, application software. Yes, about who is, and then yes, application front end, back end. So web application architecture. So Java is a backend. Same it's in document here. Okay. Software language, computer understandable, user understandable. Yes. Generation of computers, 5 generations. Same here, explain 5 generations. Okay. Software language, 2 categories. First one, low level language. Next one, high level language. Low level language, system understandable language. Same thing explained here clearly. Low level language, next high level language. High level language, yes. Okay, yes. So compilers and interpreters are used to convert from high level language to low level language. Yes. What's the difference between interpreter and compiler? This topic tomorrow we'll discuss. So difference between interpreter and compiler, yes. Minimum 1 hour explanation. So tomorrow completely class about interpreter and compiler. So what is exact interpreter and compiler? So differences. Just difference between interpreter and compiler. Next, what is Java? So tomorrow going to introduce Java. Java, compiler based or interpreter based? Java is compiler based or interpreter based. So the topic tomorrow we'll discuss. Yeah, that's all about this. That introduction. So tomorrow we'll discuss interpreter and compiler, their differences. Yes, any doubts, guys? Any doubts? That's all for today. Yes, tomorrow, Saturday also, Monday to Saturday classes. So tomorrow, same link on the same time, same link and same time. No changes, same link till end of the batch, same link, same time. Right? Yeah. Thank you guys. See you tomorrow. See you tomorrow. Have a great night.